Hello everyone, welcome to LFI Educates. In the last lesson, we learned about light. So in this lesson, we will learn about shadows. The subtopic in the chapter are light travels in a straight line, which materials let light through, ciliates and shadow puppets, what affects the size of a shadow, investigating shadow lengths, measuring light intensity, and how scientists measured and understood light. So let's get started. Light travels in a straight line. We have learned about this in the last lesson. Let us try to explain this with the help of a simple activity. We need a source of light such as a torch or a candle, and a tube or a plastic straw. When we see through the straight tube or the straw into the source of light, we can see the light. Now let us bend the straw or the tube and try to look at the light. We will not be able to see the light. This proves that light travels in a straight line. When we light a torch in the night, we can see the beam of light coming out of the torch in a straight line. What happens when a solid object comes in path of a light? For example, if we place our hand in the path of the light from the torch, we will see a dark image of our hand in the wall. This dark image is known as shadow. We see the dark image because light cannot pass through our hand, so the area behind our hand will be dark. All of us must have played or enjoyed making different figures in the shadow. Now, we have understood how shadows are formed. Since our body is a solid object, it does not allow light to pass through. Hence, the area behind our body will be darker than the area receiving light. Which materials let light through? If we place a glass in front of the light source, do we get a shadow? No, we do not see a shadow. This is because a glass is a transparent object. This means light will pass through the object. This is also the reason why we can see through a glass. There are some objects which allow only some light to pass through them. So the shadow will be lighter. Such objects are known as translucent objects. Our sunglasses are made up of translucent objects. So, from this we can learn that objects that do not allow any light to pass through and give a black shadow are known as opaque objects. Example, rocks or trees. An object which allow all the light to pass through and does not form any shadow is known as transparent object. Example, glass. An object which allow some light to pass through them and form a weak shadow or a gray shadow is known as translucent object. Example, sunglasses. Ciliates and shadow puppets. What is a ciliate? An opaque object held between a light source and a screen gives you a shadow on the screen. The shadow of the object is a ciliate. We all love to make images in the wall using our hands and a torch. Images like a butterfly or a dog and many other things, these shadows are known as ciliates. Shadow puppets. Shadow puppets are ciliates used to make a story on a screen. To make a shadow puppet show, we need a light source, a screen, and images made of cardboard, which is cut in shapes or figures that is needed for the story. Storytelling using a shadow puppet was invented very long time ago. Shadow masters use their hands and even feet to make the puppets move, and noise and sound effects are also added. In ancient China and Indonesia, shadow puppets were used to tell stories before paper was invented. What affects the size of a shadow? We have all made shadows of butterflies or other things in the wall using a torch. You must have noticed the size of the shadow changes when we move our hand front and back. So, we can say that the size of a shadow is affected by the position of the object. Here, our hands are the object. If the object is closer to the screen and far from the light source, then the shadow will be smaller. If the object is closer to the light source and far from the screen, then the shadow will be bigger. Investigating shadow lengths. You must have noticed that sometimes our shadows are long, while sometimes it's short. Why does this happen? This happens because the light from the sun is coming from different angles at different time of the day. In the morning, the light from the sun is coming from the side, so our shadows are longer. During the day or noon, the sun is above our head, so the shadow is shorter, and in the evening the sun is again at the side, so the shadow will be longer again. From this, we can say that the length of the shadow depends on the angle of the source of light placed. You can try the activity given in your textbook on page 74, activity 5.5, to get a better understanding. In ancient times, before clocks and watches were invented, they used sundials to tell time. It had markings of the time and an object in the center. The shadow of the object was used to tell the time. Measuring light intensity. Light intensity means the amount of light in an area. In the past, people measured light intensity in candle power. This was the amount of light given out by a candle. Today, people measure light intensity using light meters. Different light sources will have different light intensity. The sun will have a very high light intensity, or in a sunny day, the light intensity will be high, while a candle will have a low light intensity. So, in other words, we can say that light intensity is the amount of light present in the area. Light intensity is important for many people. For example, while making a movie or photographers, they use light intensity meters so that they can have the correct amount of light to capture the perfect video or a photograph. Similarly, in a game of cricket, if the light intensity is low, the players will not be able to see the ball clearly, so they will not be able to play. Light intensity meters is also used in commercial greenhouse to grow flowers and vegetables. A greenhouse is an enclosure where plants and vegetables are grown. Since we know plants need light to make food, so proper light intensity is needed. How scientists measured and understood light. Different scientists had different concepts about light. For example, rainbow. People did not know how rainbows were formed. So, Aristotle, a Greek scientist, thought rainbow was caused by clouds reflecting light at the certain angle. 500 years later, Islamic scientist Ibn al-Haytham thought that rainbow was like a reflection in the mirror. The clouds was like a mirror with the sun reflecting off the clouds. About 950 years ago, Sen Qiu from China suggested that the sunlight hit the rain to make rainbows. The English scientist Isaac Newton was the first to explain the rainbow accurately. About 300 years ago, he showed that sunlight, also called white light, is made up of different colors. Our eyes do not see these colors separately. Newton used a prism to demonstrate that white light is a mix of colors. A prism is a three-dimensional object made of transparent material. When sunlight passes through a prism, it bends. This is called refraction. Refraction means the bending of light when it passes from one material to another. The angle of bending is different for various colors of light, that is, red, orange, yellow, green, blue, indigo, and violet. In a rainbow, every raindrop acts as a tiny prism. The sun shines through the raindrops and light is refracted, giving a rainbow. This is also the reason why we see a rainbow after a rain. As the atmosphere is full of tiny water droplets, so the sunlight hits these raindrops and a rainbow is formed. This is all we have in this chapter. Stay tuned for more. Thank you.